Drones have been around for longer than you might realize. The first use of drones was in the 30s, when they were used for military target practice. However, while military use led the way with drone technology, recent developments have brought drones into the public sphere. In the past decade or so, drone technology has become more powerful and more affordable to the public. As drones increase in power and popularity, we will continue to see them in more and more facets of our lives. Whether we like it or not, they're about to have a huge impact on the way we live. Drones will affect us most in the areas of public service, commercial uses, and personal use. Finally, after seeing how important and influential drones will become, I wanted to learn how to make and use this technology myself. My first order of business was putting together a frame for my drone. The frame that I will use has 4 arms, which will hold all of my needed components. It's made out of plastic, so it's lightweight but still durable enough not to snap or bend while in flight. Before I attach the arms to each other, I attach motors to each arm. The motors alternate. One spins clockwise, the next spins counterclockwise. This alternation of directions helps cancel out each other's movement so that the drone remains stable in flight. Electronic speed controllers, or ESCs for short, take power from the battery and supply it to the motor. The ESCs are crucial to controlling the drone, as they receive input from the flight computer, which tells the ESCs how much power to supply. If all of the blades spun at the same speed, or they were only able to have full power and off, the drone would fail to balance and probably crash within a few seconds of flight. Here on screen, I am soldering banana plugs onto the ESCs so that I can easily connect and disconnect them with the motors at will. To add a nice finishing touch to my banana plugs, I went ahead and put some heat shrink on them so that they'd be a little more weather resistant and just take less wear and tear in general. Now, I soldered each of the ESCs onto the power distribution board. This takes power from the battery and spreads it around to all of the ESCs so that they can supply power to the motors. This board also serves the purpose of helping to hold the frame together, as it screws onto each of the arms where the ESCs are located. I finally finished the frame by attaching the top plate on with 4 screws on each arm. I figured that the hardest part of this project was out of the way, actually soldering and assembling and wiring and all that stuff. However, I had no idea the problems that I would encounter soon down the road. The first issue I encountered was that of the flight computer. The holes on the frame of the flight computer didn't quite line up with the holes on my drone's frame. I guess the parts weren't really designed with compatibility in mind. What I ended up doing was 3D printing my own part, which would kind of bridge the gap between the holes, and I ended up also using some double-sided tape to secure it to my part. I added a couple more parts off camera. The first part I added you can see on the right of the drone there. That is the radio receiver. That came in a package with the radio transmitter. It looks like a controller, pretty much standard. I mounted that, and then I also mounted the battery. And of course the battery is important because you gotta have some way to power your drone. Now I got a rechargeable battery because I want to be able to fly this drone more than once, and I also got a lithium battery charger. You have to get a special charger because if you don't charge a lithium battery the right way, you're going to have a fire on your hands. I wanted to avoid a fire, so I got a charger. I had all the needed parts for my drone, so I went ahead and hooked it up to my computer with a USB cable right through the flight computer, and I got some software called LibrePilot. It's a free open source software that lets me configure my multi-rotor copter and just get things set up. So here I am configuring each individual motor. I'm telling it that it's a multi-rotor copter. This also works for RC planes, any other RC type vehicle. But wait, there's more! And here we've encountered our first major problem. When I power it up on the setup here, I have the output value to max, and we're getting no spinning. So that's not a good sign. At least this issue is relatively minor, and I was able to find a solution very quickly. I went back through my steps, and I realized that I may have hooked up the electronic speed controllers backwards to the flight computer, and indeed, this was the problem. So all I had to do was flip him around and everything was working as intended. Luckily there was nothing seriously wrong with either the ESCs or the motors themselves. Now I calibrated the motors to find out the minimum threshold they would need to be powered.
It's about time.
After calibrating everything, I found a pretty cool feature. I found that the flight computer could transmit a live feed through the USB cable to the computer, and it could tell you what orientation it was in. I don't currently see any useful flight applications since it's only transmitting at the moment through a USB cable, so my range would be quite limited, but still a neat feature nonetheless.
Alright, so what's happening right now?
Well, currently I have one major issue, and that is that the program is not picking up that I have this remote here. It says there's no action or connection. So I'm just trying to rewire this to see if that will work, and possibly Google some more stuff, because there's nothing about it listed in the book.
It's complicated.
As it turns out, it wasn't really that complicated, but none of the solutions I was trying were working. What I had originally thought was simply a wiring issue was actually a result of there wasn't enough power being supplied. It turns out that I wasn't using one of the parts, the power module, which supplies the flight computer with power from the battery. I hadn't noticed that the computer was unpowered because all of my calibration had taken place while it was plugged in with the USB. The book said that the power module may have been an unnecessary part if the ESC supplied the power instead, and since I heard beeps when plugging the battery in, I falsely assumed that the computer was receiving power. Since the radio receiver only got its power through the computer, it was not receiving enough power to function. The final issue was that the cable coming from the module had 6 pins, while the slots on the flight computer only had 4. Only 2 of these were needed, a power and a ground wire, so we soldered wires from the flight computer to the power module, and everything was finally working. Now that most of the technical bugs had been smoothed out, it was finally time to take my drone for a test flight. All I had to do was screw on the propellers and make sure that I had the correct ones on the correct motors. One is meant for going counterclockwise, the other is meant for going clockwise. If I got these wrong, up would mean down, and that would mean no good. So here I am attaching the propellers, and I'll get to the flight very soon. Before we get to the flight, I'd like to quickly review how the drone, each part functions. I've drawn up a very simple schematic in Microsoft Paint, and this gives you a nice simplified view of how the drone works. The flight computer does most of the processing, so your transmitter will transmit whatever you want the drone to do to your receiver. The black lines in this case represent signals, so the receiver will send signals to the flight computer. And everything is receiving power through the battery, but the receiver has to take that power through the flight computer, which was my original issue because it wasn't receiving the power. And the flight computer gives signals to each of the electronic speed controllers, which also receives power from the battery. And you can see that each electronic speed controller is connected to its own individual motor, and it controls how much power is given to each motor, which controls which direction you fly in. Alright, welcome to my first official test flight. Now that I've finally finished making this drone, we're going to see if it gets off the ground. Ready?
Ready.
Will it fly? In actuality, I got pretty lucky. The drone was relatively unscathed, only a little bit of the propellers got a little scuffed up, but it didn't affect the flight at all, so that was very lucky on my part. This project was a lot of fun and proved to be very educational. I strengthened skills or learned new ones, including soldering, the process of programming a drone. This project was a test for my problem-solving skills, and I overcame most challenges pretty successfully. If I were to change anything about how I did things, it would have been to look for outside help sooner. I spent too much time sitting around and doing nothing while puzzled about the radio receiver. Unlike most of my projects though, I kept procrastination under check and didn't have to build the drone the night before my showcase. If anyone is looking to build their own drone, the advice I would give is to first be sure that the cost is within their budget. All the parts for this drone cost a little under $300, but now I have a drone to show for it. It's up to you to decide whether this cost is worth it, but for me, I think it was. For your first drone, I would recommend a smaller drone than the one that I have here, as the parts are cheaper and crashing it wouldn't be quite as catastrophic. I'd like to thank you all for watching. Whether you were forced to watch it or chose to watch it on your own free time, I still hope you enjoyed the video nonetheless.